It's my great pleasure to introduce my colleague, Elchanan Mossel. Elchanan is a professor of mathematics at Massachusetts Institute of Technology. His research is in the areas of probability, combinatorics, and inference. His research interests include combinatorial statistics, discrete Fourier analysis, randomized algorithms, computational complexity, Markov random fields, social choice, game theory evolution, and mathematical foundations of deep learning. He received his undergraduate degree from the Open University in Israel and subsequently received his master's and Ph.D. from Hebrew. He was a postdoctoral fellow at Microsoft Research and then the Miller Fellow at Berkeley. He was on Berkeley faculty for quite a few years. Actually, that's when I first came to know him when I was a grad student at Stanford and always enjoyed listening to him on a variety of different type of questions. As you can see, he's very broad research interest and takes some of the very social science questions and provides a beautiful mathematical treatment to them. And I'm looking forward to one such thing as he's going to talk about today's topic, the curse of dimensionality in opinion dynamics. So Elchanan, thank you for giving the talk.
So, I mean, if you've been to John Kleinberg's talks earlier, you know, he was talking about some very interesting models that lead to polarization, and I'm also going to talk about polarization, and I'm going to talk about one aspect of opinion dynamics that I haven't been studied in a very serious way, and that's the high dimensional or the complexity of us as human beings. So this is mostly based on a joint work with Jan Hasla, Jan Jin, and Govind Narayan. So as John mentioned in his talk, there's a huge body of work modeling opinion dynamics. I mean, from my perspective, the main three questions that people ask about opinion dynamics, at least classically, have to do with convergence. You know, do people opinion converge to some value as you run the dynamics? Agreement, do they all agree or do they reach consensus in the language that we've seen before? And maybe one question that we won't discuss now, but I just want to bring up to the forefront is the question of learning. And that's actually in models where people reach agreement or reach consensus, what's the quality of the decision that they're making? So this is something that I haven't seen at John lecture, and I think it's something that's always good to think about. That there's a dynamic that leads you somewhere, but is where you're going a good place. So the more elegant models, which we won't talk about, you know, just this is again the background, satisfy convergence. So every individual person opinion converge, and agreement, there's a consensus, what you converge to everybody is in agreement. As John mentioned in his lecture, the one classical model is the degree model, where people just average numbers, and the other one is Bayesian learning. Well, by and large, I agree with John. I mean, we know partially by some of our own work that, you know, doing the Bayesian updates is computationally hard. In fact, it's space complete. But I think the Bayesian learning is, as John mentioned again, is, you know, there's a fundamental reason for the people doing what they're doing. They're optimizing some utility or you know, so that's a very natural reason that economists have looked at. So I don't want to say too much about this. I mean, you know, if you want to read more about this, and in particular questions that I was interested about is learning, let me encourage you to look at this fantastic survey here. I'm, you know, or not so fantastic, but, you know, that I wrote in collaboration with Omer Tamuz, and, you know, this is opinion exchange dynamics. And there, you know, a little bit differently than John talks, there's more emphasis on the Bayesian learning, and also questions of learning, of the quality of what you converge to. Okay, so that's sort of the background. I just wanted to summarize in one slide what we're not going to talk about in this talk today.
Okay, that's, yeah, so Elchanan, if there are questions in chat, I will always read out to you and interrupt.
Yeah. Maybe I'll just mention another one point. If you actually look in this opinion exchange dynamic, and for those of you who do more EE or control kind of things, there is actually one model of Bayesian learning. So maybe I'll just note it here. There's that if you want to look at, there's the Gaussian model, with improper priors. So this was mentioned briefly again in the talk, at least the citation. There's a paper by De Marzo and collaborators from Stanford, where in the Gaussian models, the computations are actually efficient. So for those of us who are looking to the best of all worlds, a model that's as deeply good foundations in terms of theory, and the computations can be carried out, is a nice model to look at, and I think there's interesting questions to look at there. Okay, but this is not what we're here to talk about. We're here to talk about polarization. Again, in all the models that I mentioned before, there's consensus, and this is not what we see in real life. And in fact, for me, as somebody who started working from the Bayesian perspective, interestingly, this was already pointed out in Umann's paper that actually led the foundation to Bayesian learning. And the title of this paper is Agreeing to Disagree. And one paragraph from the paper reads the following: the results of this paper might be considered evidence against this view, as there are in fact people who respect each other's opinion and nevertheless disagree. So that's what he said. I mean, in fact, in this model, he was trying to argue, in this paper, he was trying to argue that to some extent, the Bayesian model cannot be viewed as a realistic model because people can respect each other and still agree to disagree. Still, this paper led to a huge body of work on Bayesian learning, where in most of this model, people agree. So of course, this is just a note. It was noted very old, even in the econ literature, that people do not agree. So there are many mathematical models that explain polarization, and John mentioned many of them, and I'll just do injustice to many of them by mentioning some of the key dynamics that lead to polarization. So, I mean, maybe the first model that John described today, let me call it, very informally dishonesty. People do not report what they actually think, they report something else. And then people do not reach consensus, they do not agree. Some of the other models that we've seen at John lecture have to do with peer interaction. You mostly talk to your peers. Homophily, I mean, again, it's a different way of saying that different people talk and see different things. Or what these days people call echo chamber. All of these notions are related to each other. So I'm not going to talk at all about these notions, but for those of you who have not thought about polarization, it's good to look these things up and see what they say. We are going to go in a slightly different direction. And this direction, again, is very old. It goes back at least to the 1970s. And this is called bias assimilation. And maybe we've seen a little bit of that too. And the basic direction, the basic idea there is that, if you see something that you agree with, you make your opinion on that topic stronger. If you see something that you do not agree with, you say, oh, this cannot be true. So somebody's, I don't believe it. I'm going to make my opinion even stronger in that direction. And what we'll see today is we'll see what is the effect of that in high dimensions. And like I said, I mean, we are definitely going to take the point of view of bias assimilation, and we're going to ask what does it say in high dimensions. In particular, there's a bunch of studies, I'll mention another one in a little bit, and this is a more recent one by Bale et al. And it says that social media users who are assigned to follow accounts or are getting paid to follow accounts that share opposing opinions hold their own political opinions, and sometimes they even go to more extreme opinions, right? So, seeing something that you do not, that does not align with your opinion is not going to make you change your mind. It's actually going to push you in the opposite direction. Okay, any questions so far about the introduction? Okay, good. So, I mean, maybe to motivate what we're doing, I mean, let me say that the models above explain why opinions are polarized on each particular topic, but they do not explain why do the issues align. So let me try to explain in simple terms what do I mean by alignment. So if you look at the political spectrum in the US, you can pretty much predict somebody's views on gay marriage from what they think about abortion. And once you know what they think about abortion, you also think what they think about guns and the ability to possess guns and use them, and what they think about taxation and so on and so forth. So it's not just that in each particular topics, the opinions are polarized, they're actually polarized in a way that, there's many deep topics where all the left is taking one opinion and all of the right is taking another opinion, right? So this is a stronger notion than just polarization in each topic, and that's what we're going to try to understand. So mathematically, as a mathematician, let me try to draw what is the difference between these two points of view. So even though what you see here is just drawn as a circle, you really have to, I really want you to think about it in the, in some high dimensional space, maybe out to the 100, maybe there are 100 important topics that people think about. So this is maybe the 100th dimensional, the 100 dimensional sphere. And then we have all of the people who are like, confirmed leftists, so they have all the supposed opinion of the left, and all the people are confirmed people of the right or Trump supporters. Of course, there are some other people, but most of the mass, maybe if you ask people in the US, is concentrated around this point. So this is an example where we have both polarization and alignment. And this is an example where just a polarization. Okay, what I've drawn here mathematically is just a discrete cube. It just says that each person has very strong opinion on topics, but maybe I'm pro-gun, pro-women's right on their body, pro-minimal taxation, I don't believe in climate change, right? So I'm somebody who doesn't exist today, right? I have very strong opinion on very topics, but they do not necessarily align with these 2 points. Okay, so the difference again is in both pictures here, the opinions are polarized on each individual topics, but on the right picture here, we also have alignment of the different topics. Okay, so maybe just to make this more mathematical and to think what does it mean, let's look a little bit more carefully at these 2 examples before we motivate our model a little more. So one way to define polarization on topic I, so this is going to be one specific topics, maybe gun rights. So there's this row IS here. So what I try to do is I try to partition all the views that I have on these topics. These are these dots into 2 sets. There's the set S and there's the set U minus S. And what I'm looking at is I'm looking at the energy of this partition. So I'm looking at the difference of opinion between everybody on the left side and everybody on the right side, right? So that's a natural, so this is U and S minus mu. I switched the notation. So that would be polarization on topic I, and similarly, you can define the overall polarization. So the overall polarization, I just try to partition all of the opinions in my big dimensional space. I'm going to partition into 2 sets. There's going to be U and the complement of U, and then I'm just going to sum over all the pairs of the distance between the corresponding opinions. And once you look at this definition, it's pretty clear that the overall polarization is bigger than than each individual topic polarization, and it's less than the sum of polarization. And somehow the gap between what's written here and what's written here is a good way to measure the difference between having polarization or the amount of polarization and the corresponding alignment. So let's look at our example that we had from before. So in the example of the discrete cube that we had over here, what you had is that you have that the overall polarization is about half the sum of the polarization. And the antipodal case, you get the extreme situation where the overall polarization is the sum of the polarization, right? So this number 1/2 really plays an important role because the picture that you have on the left is that if you let 2 random people meet, in half of the topics they will completely agree, and in half of the topics they will spend the night talking them out and arguing very harshly, right? So this is an interesting society somehow, right? People agree on something and they do not agree on something, and when they do not agree, they don't agree the most. On the other hand, if you look at the right-hand picture, what will happen if you look at 2 random people? Either they completely agree on everything and then they are bored, like maybe we have in our bubbles in the left and in the right, or they completely do not understand the other point of view on any topic. Okay? So, why did I start to think about this high dimensional question? So I started thinking about these high dimensional questions when, I started reading about, what actually happens in the modern campaigns in social media. So let me not try to say the name of this book online. This is a very fascinating book by Christopher Wiley. So, this is a gossipy book, but as a scientist, if you read it, you understand that the modern campaigns that are used in social media are very high dimensional. So I won't describe all of the campaigns that they were taken, but they collected layers on layers of data about users of social media. They crossed it over with their consumption and with their tax records and with their voting records and so on and so forth. And the campaigns used very high dimensional sets of data in order to persuade voters or people to do what they wanted to do. So of course, I mean, for those of us who are less theoretical, people are thinking about it hard and they're trying to look at data and understand. And interestingly, yesterday there was actually at Stanford, there was an event for this book that is forthcoming. It is called Social Media and Democracy. And a lot of the questions that we asked there in sort of a more mathematical way were also asked in that setting. And when you talk to people in that setting, it's clear that, it's clear at least from some of the talks that you go to or some of the chapters of the book that you look at, that, the campaigns that people run today are high dimensional, and we cannot avoid this high dimensional nature of the campaigns. So maybe, I don't know how many of you have followed the Cambridge Analytica story, but let me just tell you a little bit. I mean, one of the things that the way that Steve Bannon decided to use Cambridge Analytics is he recognized a group of people that, he called them, I guess in the book, they call the beta males. So these are white males that are frustrated, that are not successful, and therefore, do not get as much sex as they want from the opposite sex. And he decided that he's going to weaponize this group of people. In order to weaponize this group of people, one of the things that he did, using social media, he was able to identify exactly who are this group of people and how to harness their power in order to push his political agenda. Now, of course, maybe mathematically, there's nothing new in this point of view. I mean, if you look at the marketing literature, this is an example of a paper from 1977. There are other papers from this era that talk about the same. So this is in particular a paper that says, if you have a democratic voter, they will have these characteristics, and this is how you use it in order to run your campaign. And if you have a Republican customer, if you have a democratic customer, this is how you're going to run your campaign. If you have a liberal customer, if you have a conservative customer, this is how you should run your campaign, because these are the values that they believe in, and this is the right thing for you to do. So I think in the marketing science, this point of view was people were well aware of. I think that the new twist is that now it's done at a scale, at speed that we haven't seen before, using the data that's available in social networks.
Elchanan, if I may interrupt.
Yeah.
So is the intuition behind this question, this, let's say, degree of alignment, is that if things are very well aligned, then maybe there is, even though number of topics or opinions are very high dimensional, somehow there is some lower dimensional structure that is explaining how people's opinions are formed across all of them, and hence maybe they are more predictable.
So that's definitely one option, but we are going to take a different route. So we'll get there in a little bit. We'll get there in a few minutes, right? So so there's definitely you can definitely imagine that there's correlation between topics that are close by, but the mechanism that I'm going to describe is going to be a little different.
Okay.
Okay, and again, I'll just mention another paper, earlier paper from 2010 that talks about the fact that this is going to be very important in our model. That's the reason I repeat this over and over again, that individuals who receive unwelcome information may not simply resist challenges to their view. Instead, they may come to support their original opinion even more strongly. I don't know why there's a question mark here, what we call a backfire effect. So this is a very highly cited paper from 2010 by Nayan and Reifler. Okay, so now I'm done with the introduction. I can tell you a little bit about our model. So our model, my goal or our goal in setting up this model was to find a very simple model that will explain why campaigns in high dimension, like the campaigns that people take in social media these days, results in polarization, and why they result in polarization with issue alignment. So that's what we're going to understand. So we are going to represent the opinions as U, and these are going to be d-dimensional vectors. So U is going to be in S to the D plus 1. S to the D plus 1, for those of you who haven't seen it, this is just a way to draw the d-dimensional sphere. Okay, so Maybe it's the simplest mathematical model for opinion. Everybody has the opinion. We want to normalize somehow. Maybe people don't have infinite energy for all topics. So we normalize it that the sum of the opinions that they have on different topics, the sum of the squares has to be 1. Now there's going to be an intervention. Intervention is the same as campaign. So a campaign is also going to be a vector V. V is also going to be a vector in the sphere. And U is going to update to a vector that's proportional to the following. So this is the main equation of this talk. So let me explain this slowly. So my original opinion was U. Now I was exposed to a campaign V. The campaign V has many topics in it. And what I'm going to do is I'm going to look at the inner product of my original beliefs on these topics with the vector V. This is going to tell me how much I'm going to like the campaign. Now that I know how much I'm going to like the campaign, I'm going to go this much in this direction. And there's a parameter eta here, which is positive, but without loss of generality, we assume that eta is equal to 1. It doesn't really matter any of the analysis that we're going to carry out. So again, what is the assumption? This is again very much in line of bias assimilation. Somebody is showing me an ad. Maybe they want to maybe they want to convince me. I don't know what's. Maybe they want to convince me to wear a mask. Okay, so maybe they try to convince me to wear a mask. They see a family, maybe a gay family, driving a car, which is a hybrid car, and they have 2 kids. And this makes me very happy because I'm aligned with many of these topics. So I like this campaign. I see that they all wear masks. I'm also going to wear a mask. On the other end, another viewer is going to see the same ad, is going to say, who are these people who drive these stupid cars? They don't drive pickup cars. And what is this about gay couples? I don't like it. I'm going to, the chance that I'm going to wear a mask now get even lower. Okay. So if you notice when I describe this update, I mean, so this is a very simple model. By no means I'm claiming that it's explaining everything that we're saying, but I'm trying to come up with the simplest model that has the features of these high dimensional campaigns that we see, that explains maybe a little bit of what we see, right? So there's no social network here. The campaign is applied to everybody. Different people have different opinions. They have different reaction to the campaign, and they update the view of the world. Maybe one more technical point. I said that this vector is proportional to this vector. So why did I say that it's proportional to this vector? W in general is not going to be a unit vector. I want to stay in the sphere, so I normalize W. So the new opinion is going to be W normalized, so its length is. I know I asked for question 5 minutes ago, but I think this is a very good time to ask questions because that's the model I'm going to talk about from now on.
And so the population, we should think of like as a distribution on the sphere.
So the population is just a discrete distribution on the sphere, just a bunch of points on the sphere, right? So I just have a bunch of points. This is originally I have everybody opinions because I'm Facebook, right? And I don't really even care about the social network. There's just a bunch of points on the sphere. Now I'm a campaign. I'm going to apply the campaign. I don't want to worry about targeting. I don't want to worry about any of the other aspects we can think about later. I'm just going to apply this campaign to everybody with the goal of achieving whatever goal I want to achieve. I get, all of the opinions shifted a little bit and so on and so forth.
So Elchanan, so here the V is assumed to be like a constant across the dynamics, remain to be a constant.
So this is very good. So this is one intervention. One question that we'll ask in a little bit is, suppose I'm a campaigner, suppose I'm Steve Bannon, and I want people to vote to Trump. Am I going to use the same view over and over again? Or am I going to do something else? So we'll ask this question in a little bit, right? So in particular, there's one of the questions that we ask in this paper is, what is the difference between a one-shot game, where you're only allowed to do one campaign and you have some objective, versus the situation where you're saying, okay, I actually have a lot, I'm maybe some Republican think tank or some Democrat think tank. I'm going to apply a campaign for very, very long. I'm allowed to change my V during time and see what I can get. So we are going to ask both questions. We're actually going to start from the later one. I can run a campaign for a long time. Excellent question.
So you say there's no network. So, but you have a campaign statement. You have maybe 2 campaigns.
For now, I just have one. For now,
you just have one campaign, and there's no and there's no network.
Right.
And so, but are the campaign that the campaign is trying to convince some segment of the population to accept its program, right?
Yeah, which
And so but there's no network.
no
So
network.
what is the properties of the interpersonal influences that are involved in getting people to adopt the campaign platform? Or do you?
It's all of it is about, I agree, all of these questions are excellent questions. And I think, if you really think about what Cambridge Analytica did, they did take into account these other aspects too. They asked, oh, maybe it's better for me to invest in people who will change other people's opinion and so on and so forth. All of these questions are interesting questions. But what we want to do in this work is just distill what is the high dimensional, the fact that life is complex and there are different topics, and I can use one of them in order to change your opinion on the other one. What does that do?
Okay, thank you.
That's all we do. It's very simple, and the goal is to be simple and see what does that do on its own. Excellent questions.
Okay.
Okay, so let me go on and tell you what are the main results of the paper. And the main results of the paper is maybe, not surprisingly, after you think about this a little bit, these campaigns lead to polarization, and they lead to polarization in the strong sense that I described, right? If you run campaigns in many different settings, I'm going to talk about many different settings, but in many different settings, what will happen is that the society is going to end up like our society. There's going to be two antipodal points, and this is where the society is going to end up. Okay? So I'm going to give more details later about various situations where this happened. Sometimes it's a little more complex than that. We have a bunch of results in the paper, but you can, in all of our results, you see that campaigns lead to polarizations. And like, if you ask, in this model, there's no peer effect. We don't use anything about the network structure and so on and so forth. This is not to say that these do not play a role. Again, if you look at, either of the two books I was talking about, either the Cambridge Analytica book or the Stanford books, they also talk about all of these other effects. These effects definitely play an important role. I just don't want to talk about them now. And I think it would be interesting future work to overlay what we're seeing here with the other effects that are clearly there. Okay, so now I don't know if anybody stated theorems like this in this workshop, but let me state some theorems, and maybe I will also try to play a video. So obviously we did everything in the last moment, but Jan Hasler, sorry, I said JH, so this should be reversed. Jan Hasler, it's alphabetical. So Jan Hasler kindly agreed to make some videos for me, so I'll try to play them. We'll see how successful So I'm going to start from the easier statement maybe of polarization. So we are going to start from, let me draw the picture again. Maybe the picture is always, even though I draw it in 2 dimensions, really you should think about it in SD+1. This is very high dimensional. So here I'm going to start with 2 individuals. And what I'm going to do here is I'm just going to say that people are exposed to random campaigns, right? I'm not, I don't really, one day you're exposed to one campaign, another day you're exposed to another campaign, another day you're exposed to another campaign. So what I start for is the original opinion U and V, these are on the sphere. And after T campaign, U's opinion is becoming UT, and V's opinion is becoming VT. Okay, so this is the opinion after T days. So what will happen, and let's not worry exactly about what the probability, and what will happen is either the opinion of U and V will become the same, or they will become antipodal. That's what happens in the limit. With probability 1, when you apply random campaigns, people will either completely agree in all topics, they will have complete alignment, or they will have completely opposite opinions. Again, we can even calculate as a function of how close the original opinions were, what is the chance that they'll end up being completely opposite, and what is the chance they're going to end up exactly the same. I think this number is slightly less important because if you take slightly different distributions about the intervention, you will get different numbers, but you will still get this phenomena. You will still get the phenomena they either agree on everything or they are going to disagree on every topic and be completely polarized. Okay, so that's one instance of the fact that we see that things lead to polarization. And now, if I'm brave, you can ask questions, and I will try to share the video. Let's see if I can do it. maybe after one video, you will not want to see any more videos. So let's see. I will try to share my computer screen now. I will try to run the video. Can you see the screen? Mickey, yeah, okay, good. I can see you, so I can ask you. Okay, so this is what happens. Even though it looks two-dimensional, in fact, it's three-dimensional. The 3 dimension is in the color. This is what happens when you just apply random campaigns. Okay, so you just see that things get completely polarized when you do that. Okay, so can continue and continue and continue.
Sorry.
But yeah.
In each day, there's a new random campaign happens. Yeah.
In this result, we are also going to talk about another result. In this result, in each stage you have a random campaign. Next, we'll talk about some other models of campaigns. Yes.
Thanks.
Okay, let me share my screen again. Thank you, excellent question. So let me share my screen again. Go to the slides. Okay, so that's one result that shows some of the phenomena that we talked about. But now I want to talk maybe about a different scenario, and that's the scenario that first I had in mind when I thought about the Cambridge Analytica story. So here's the story. There's just one single advertiser who's super smart. And he can apply, this advertiser can apply a large number of iterations, not necessarily of the same vector. And really, when I thought about it, I thought about Steve Bannon, because I think that Steve Bannon maybe is evil, but he's very smart. So, that's what he wanted to do. He really wanted to apply some campaign in order to get people to vote for Trump, or maybe Putin. I don't know, maybe these two guys are aligned. And what's the advertiser goal? The advertiser goal is to get as many people as possible to have the opinion V star. They really want, people to have their opinion that they want. They are the king. They should rule forever. They and the sons and their daughters and forever. That's the opinion that they want to do. The question is now we're, sort of in optimization problem. We're asking this campaigner is the only campaigner in the world. There's no game theory. There's no, what should this campaigner do in order to get as many people as possible into this stuff? And sort of surprisingly, the optimal algorithm is very close to what you read about what Steve Bannon actually did. Okay, so this is kind of shocking. If you see what they actually did, it's very close to the optimal that I'm going to describe. So what we proved in our paper is that the optimal strategy is the following strategy. First of all, you find the densest hemisphere. So you find the densest, the half sphere, which has the maximal number of points. So let's look at this half sphere. Then I'm going to look at the center of this hemisphere, which is called W. Then I'm going to apply W over and over again. So I'm going to apply W again and again and again and again and again. What will this result to? It will result in something that is very close to the fact that all of the people are going to be essentially at W. Everybody in my hemisphere was in this. And then all of the people who were in the other hemisphere are going to be wherever they were. Okay, they're going to be in the opposite hemisphere and they're going to be antipodal. So first of all, you get everybody together. Maybe you make them hate somebody much. Maybe you bring some topic that brings all of them together. And once you bring all of them together, so once you bring all of them together, you slowly flow from W to V star. So if I draw the picture again, we had this was the densest hemisphere. Then we moved to a situation where essentially everybody in W, but maybe in fact the real opinion that I want to go to is V. So slowly I will take inner products that will shift W slowly. It will slow from W to V. So we can prove that that's the optimal strategy. If your goal is to you have unlimited number of iterations, you can also get bounds in terms of how close you are and so on and so forth. But let's assume you have infinite number of iterations. All you want to get is you want to get people to V. You find this half sphere with the maximal number of people, then you apply it over and over again. Now, if I compare it to what Steve Bannon did, this is not exactly what he did because he didn't have infinite amount of time. He was looking for these beta males who were already pretty close to a point, and he just pushed them a little more towards the point and then started shifting them to an opinion that was actually not too far, right? So if you want to think about how this corresponds to real life, there are more restrictions, obviously, right? It's not all the picture, but something like that definitely played a role in what he did. Question. So I saw there were some questions in the chat. I don't know if they're still there.
Yes, I think the Vijay asked questions saying that, do you know the locations of all agents, that is U vectors in the D-dimensional sphere?
Right,
and
that's the assumption.
Yeah. Somebody answered it on your behalf, yes.
Right. So the assumption is that advertisers know everything, right? So again, when we're going to talk about future work, I mean, this is just a mathematical model that, you know, aims to explain maybe one of the mechanisms of polarization. But when we're going to talk about future work, obviously one of the questions is, what do you do when you only have partial data? But, you know, if you look at this book by Cambridge, about Cambridge Analytica, you know, the assumption there is that, you know, after, you know, they sent some people some up and they said, after 10 clicks, you know a person better than, you know, the co-workers. After 100 clicks, you know them better than their wives, right? So the assumption is that they really know people very, very well. Okay, so this is an optimal strategy, and obviously this optimal strategy leads to polarization. So, you know, that's another instance where we see polarization arising. And yeah.
So I guess if you want polarization, you don't necessarily have to be aligned to some particular V star. So if you just wanted the points to be as far apart, so then
right. So yeah. So very good. So I mean,
you would just hit in a particular direction.
Right. So very good. If you want to compare this to what say John talks or your work, where the only goal is to get polarization, you don't need the second stage. Right? You just do the first stage, and then once you do the first stage, everybody will be polarized, and you don't care about shifting them around. Right? But our original motivation was that I mean, maybe this is actually the difference between Bannon and Putin. Bannon wanted to push to a particular direction, while Putin only cared about the first stage of the algorithm. He only wanted people to be polarized. Excellent question.
So this is optimal. Like,
it is optimal, right? This is optimal also for if you want things, people, well, no, so I should be more careful. If you want, so let's think a little bit about this carefully, right? So if you want things to be as polarized as possible, what would you want to do is you want to take a half space that cuts into two sets of the same size, because you want half of the population here and half of the population here. Here, our optimization perspective is different because we want to get to a particular opinion. We want to maximize the number of points in the half space that we control.
But after that, it's the same.
After that, it's the same. Other than that, it's the same. Good. Okay, so the optimal strategy leads to polarization. Now, I mean, I don't think the following theorem has any implications on real life. I think the dimensions of the campaigns that people are looking at, you know, is not million dimensional. It's probably in the hundreds. But, you know, in terms of computational complexity, if the dimension is going to be very hard, then finding the densest hemisphere is computationally hard. And, you know, again, I don't think this really impacts practice, but in principle, there's something hard going on here if you look at high dimensions. Okay, maybe I won't show you another movie. There's a bunch of other stuff I want to tell you. I think you believe me that I can show you another movie where things polarized, right? So maybe I don't need to do that. Okay, so I want to mention, sorry, there's another question. Let me look at it.
Yeah, so the strategy is optimal with respect to what?
Very good. So the objective is to get the maximum number of people agree with the opinion V star at time infinity, or getting very close to V star at some large finite time.
So just ask, time doesn't matter, the number of interventions that you need to do.
Yes, so time is measured in the number of intervention in campaign steps. Thank you very much. Exactly. Yeah. Okay, so maybe just so you get a flavor of the spectrum of questions you can analyze with this model. And again, I think that maybe I think this model is not too far from what some of the aspects of what people actually do. I wish we could know more about what the KGB or the information agents do, or what Cambridge Analytica did. I think it's not too far, but I think what's nice about it is you can analyze it. And here's another example of what you can analyze. This is the short-term perspective, right? I'm only allowed to apply one campaign on all of the population. And suppose originally on this campaign, people have no opinion, right? So maybe I'm a Democrat who is registered in Massachusetts, and, you know, I don't really follow the local politics, and I have to decide between Kennedy and his competitor who I voted for. I already forgot his name, right? So I have to decide between these two. I have no opinion, and somebody has to convince me as fast as possible. So what the objective will be? The advertiser would want to maximize the number of people or agents such that the new coordinates UD plus 1 at time 1 will be bigger than some threshold that would actually make them go vote. Right? So that would be the campaign. And again, this answer is that the optimal campaigns reduce to finding the densest cap. So now it's not the densest hemisphere, it's the densest cap, maximizing the number of I such that UI times some V is bigger than some constant C. Okay, so there's something to check. but it's the same level of sophistication in terms of linear algebra, which is to say it's not very sophisticated. Okay, so we see the same kind of phenomena of the same kind of phenomena in this setup. Okay, so maybe I want to spend quite a bit of time on the conclusion, so I'll just maybe mention some other variants that we talked about in this paper briefly that I didn't want to put slides on. One is what happens when you have two advertisers. And it turns out that there you also get to some polarization, but the polarization is a little different because, okay, it depends on the intensity where you apply the two advertisers. So it leads to, I won't tell you what it is, but it leads to some slightly weaker notion of polarization. And we also did some more low dimensional game theoretics models, which, you know, because of time, I wanted to discuss in depth. Okay, so what I do want to spend the last 10 minutes maybe is on, I think, interesting variations of the model and possible future work. So I think some of the things that definitely come up from reading the Cambridge Analytica story and the social scientists who follow this is that, you know, I think better models of what happened will include targeting. So targeting, of course, means that influencers can target different subsets and apply different interventions. I think this is even without social network, right? There's no social network, you just know people's opinion, and you apply different vectors on different people. And the question is what can you get from that? I think this would lead to, in some sense, to even stronger polarization, but I think this is a model that we didn't think about in detail. And I think another aspect that's very important and definitely did play a role in the Cambridge Analytica campaigns is the peer effect, right? So especially if you have budgetary constraints or you have information constraints, you have to think carefully about who do you show the campaigns to, and how is that going to affect other people? So I think even in our model, there's some interesting questions to ask. And another real interesting question is what happened, you know, assuming that both sides, you know, say both Democrats and Republicans are starting to be sophisticated. What's the strategic setup for competing influence? But I want to raise up two questions which I think are more important, and I think these questions became crisper to me when I thought about this talk. And you know, this model somehow suggests that, you know, once you start campaigns, you're going to get polarization. So, you know, it's sort of saying, oh, if people talk, then, you know, you're going to end up in a polarized world. And I think all of us have some natural resistance to this point of view, because we actually think that people talking is something that can be beneficial. And I think there's a fine point here that is worth to study in more detail. And I'll just highlight what this point is. In particular, we have to think about very carefully what is the meaning of my opinion on some topic being zero. So I'm just going to give you two interpretations of what is the meaning of my opinion on topic being zero. So in the first interpretation, it means that I have no opinion whatsoever in the topic, right? So this would be the example of the Democratic primaries in Massachusetts, right? Somebody telling me there are these two candidates. I don't know anything about them. I have to decide who to vote for. So I really have no opinion on this topic, okay? The second setup, and this is another situation where many of us have opinion which is zero, is I actually thought about the problem very, very long. I studied both of these candidates' history in much detail. I talked to them on the phone. I look at their financial statement. I talked to their staff members. And after all of this, I decided that I really cannot decide between these two people. Okay? So what I think is important, it's important our model does not distinguish between these two things, or in fact, our model, I would say, take the first point of view. It's assumed that when I have a value zero, it's because I didn't think about it. And in fact, our model assumes that we do not think at all. All we do is we act instinctively. Some of us show us, you know, which is what corresponds to advertising campaign. Some of us shows us information that unconsciously aligns with what we believe in, we are going to like it. Somebody shows us something that unconsciously or barely consciously align with something that is opposite to what we think of, we are going to go in the opposite direction, right? So our model is sort of really an advertising model, right? You are exposed to information very fast, not deeply, and you change your opinion just according to association with different topics. I think what would be interesting to do, and I think this I think is very important future work, I think in this model, in other models, is finer models of individual opinions, in particular finer models that will distinguish between 1 and 2. Right? Because if my opinion is really that the 2 Democratic candidates from Massachusetts are not distinguishable because I studied many things about them, the chance that the campaign will change my mind is very, very small. And on the opposite side of that, you know, we have to think about mechanisms that are not advertising, like education, meaningful exchanges, and so on and so forth, and a way to model them in a way that actually people have strong opinion that are based on a lot of information and that are hard to change. Okay, so I think this is a very important question for future work. And it's also to say, you know, other than the many limitations of the work I presented, there's no social network, there's no peer effect, there's so on and so forth. I think this really, the meaning of what is the meaning of an opinion on a topic, we have to think about it more carefully if we want to include information that's just not very superficial ad campaigns. Maybe one conclusion from our work is that advertising is bad. And I actually believe that advertising is bad, so I'm happy to go with this conclusion. And other sources of, other ways of changing information are maybe more meaningful or more beneficial. Okay, so I'll have to.
Elchanan, there's one question in the chat by Helmut Naumer. Helmut, if you are there, feel free to unmute and ask question. Otherwise, I will read it out for you.
Sure. I was wondering if this model allows any sort of like a splintering of these polarized positions, in that, I guess what I'm thinking about is I grew up in Boulder, which tends to be, if we're thinking about as politics, very much left-wing, but doesn't tend to take the traditional left-wing stance when it comes to guns, for instance. So I was wondering if this model always leads to a full polarization to everyone agrees on one of 2 different sets, or if there's the ability for some small subset of views to sometimes be flipped for individuals.
Right. So let me say a bunch of things about that. Right. So this model, one thing that I didn't mention at all, this is not does not answer your question directly, is but there could be some universal value that we all like. Maybe we all think that cats are great, right? And therefore we will all have, you know, the left would have cats, you know, there will be cats, you know, cats, very tragic videos of cats that, you know, were victims maybe of gun accidents, and this would be terrible, and they would be against guns. And the right would have cats, you know, shooting guns, and people will say, oh, how cool it is, cats are shooting guns, right? So we can imagine that there's some universal values that everybody, or universal things that everybody likes. And according to, you know, this model, we can get everybody to believe in what we view. And you have to take it, what we believe is that, you know, polarizing issues or issues where people have different opinions are people that people care about more in general. Okay, so that's why, you know, when you run campaigns, you would not run it for using cats most of the time. Maybe a little bit, but you will not run it using cats. The other aspect that I didn't talk about in detail is, and because we don't understand completely, is what happens when you have many, many different advertisers, right? So we have one model with 2 advertisers or 2 campaigns where people get to polarization, but the polarization there is not to 2 points. It's to 2 convex sets where and maybe your Colorado setup could fit into that. When you have more advertisers and maybe there's more game theory, you know, you can maybe get other results. I think possibly what's happening in Colorado is that either there was not enough time for the standard left campaigns to make it. I don't know what is the trend, but it could be that in 50 years, you know, Colorado would also be completely anti-gun. It could also be that what we see in Colorado is partially due to the fact that there's targeting, that people, you know, in rural areas are exposed most to advertising about hunting and so on and so forth. And that's not included in our model where everybody is exposed to exactly the same answer. I hope this.
Thank you.
Yeah. Maybe other questions before I think everybody who needs to be thanked. Okay, so let me do the thanks, and in the meantime, you can think about questions. So these are some.
Miklos has one more question.
Okay, so I'll let you ask after. Okay, so these are some of the funding agencies that help me try to understand, or help us try to understand polarization, and these are my collaborator. So Yajin is right now a grad student at IDSS at MIT. She's going to graduate next year. So if you have an amazing job for her in this job market, let her know. Jan Hasler was a postdoc with me at MIT. He probably now is a postdoc at ETH. He may also be looking. And Govind already gave up on academia and left to industry. So they're all terrific, and I want to thank them. So I'm happy to take more questions now.
Yeah, I was just wondering a follow-up on your previous slide. So in order to like decrease polarization, so is it the case that if suppose there's no universally liked topic, then is there no way of doing advertising to get people less polarized?
Right. So there's yeah. So
like, is there some statement along these lines?
yeah, there is a statement. I'm just trying to. It's in our paper. I'm just trying to find, right. So what is the statement? So there is a statement. It just doesn't come to my head right now. Once there's a certain level of polarization, you cannot unpolarize it, right? So that's just the fact of this model. But,
I have another question.
Hi, Matt.
In thinking about this model, I wanted to interpret the advertising, because it seems that when you're advertising on all dimensions at the same time, right? So it's
right. So the way I want to think about it really is some of them are hooks for the opinion I want. So I'm an advertiser, and I'm going to spend some of my energy on the hooks, which I don't care about. These are going to be the coordinates that are just going to hook you to take my opinion. And all of the rest of my energy, I'm going to actually spend on the topic that I want to push. Right? So suppose I'm an advertiser, say, okay, 50% is going to be the hooks. I'm going to show you this view and this car and this thing that I don't care about, because what I care about is the math. And 50% is going to be about the math. Okay? So even though the model looks symmetric, if you're the advertising who is planning it, you will be very, very careful in choosing the coordinates that are just there to hook you and the actual coordinate that you want to push.
right. But also, I guess it means that people, even if something is, if somebody expresses an opinion just on one dimension, or I interpret that, the way I interpret that opinion depends on what I view their other dimensions are. So for instance, if I see some particular news source have a story that has a particular direction to it, I would interpret that particular story very differently based on which news source it was, because that would represent the rest of the vector to me, right? So I sort of know what their opinions are on many other dimensions, and then I would interpret the story very differently based on whether that story came along with a different vector. Right? So somehow the way I adjust depends on
it is the case, but let me just make, if suppose my campaign is just a unit coordinate, in the sense that my campaign is just the vector 1, 0, 0, 0, 0, 0. Yeah. Okay, so what would it do to you, right? So, you will ask yourself, what is my opinion on topic number 1? And depending on what is your opinion on topic number 1, you are going to either make this opinion stronger or weaker, depending if it's positive or negative, right? So in that sense, it is true that most of the time when you look in your example, I mean, this wasn't your example, but in your example, when you look at a media source, you usually already have a high dimensional. So this is the New York Times. I know what they think about A, B, C, D, or this is like, but at least ideally, you can still get the one-dimensional picture. If really they just talk about one topic, it's really just going to change your opinion on that topic.
Mm-hmm. Yeah, as long as I don't enter coordinates for those other dimensions, right?
Right, exactly. Yeah. Thanks. Yeah.
So I have a question. So let's not use the word advertising, but consider the U.S. Congress. Okay. So periodically, they would have elections, and there'd be various platforms. The Republicans would run on something, and the Democrats would be opposed to it. There's certain divisive issues. that are ongoing. But for decades and decades, there was a lot of bipartisanship in formulating laws. Despite their, stated opinions, they'd reach, they'd come to a bipartisan compromise on issues, on spending bills and the like. Well, then when Newt Gingrich came onto the scene, that set in motion a polarization process that increasingly increased in its depth. And it took a huge amount of interpersonal work. I mean, it took a lot of work to get to the state that we now find ourselves in. Okay, hard work to get these, to get a situation in which there is minimal bipartisan support.
I agree.
So how do you deal with it?
So
that's
let
a
me
more sophisticated, hard interpersonal work. Okay.
Right.
So how does that fit into? How does your model capture things like that?
So fantastic. This is exactly the point I was trying to make in my last slide. So I think in the political process, the political changes that you described in the US in the last few decades go line in line with the fact that the discussion is becoming more and more campaigny and less substantial. Right? It's less about the fact. It's more about all kind of buzzword or phrases or association between different topics. And we can talk about the news media outlets that did it before Facebook. We can talk about Fox News and so on and so forth. But what they did, to some extent, in my view, is applying the same kind of intervention that I'm talking about here. I'm going to want to say something bad about somebody. I'm going to associate all the other bad aspects that people among my viewers think about them, and then I'm going to say that what they said, the new topic is also bad. This is exactly the kind of campaign that we are discussing in this paper. What we do not discuss in this paper, which I think is harder to do, but is important to do, is how do you model, bipartisan discussion? How do you model people actually sitting up in a room, understanding each other, changing their opinion in a fundamental and not superficial way? Okay, so that's the distinction, exactly the distinction I was trying to make in the last slide between advertising or superficial update of opinions and learning or exchanging opinion, which leads to a more fundamental change of opinion, which our model does not cover. And I think this is a very important topic for future work. I think to some extent, advertisers do not want to think about it. And because our world is moving more and more to a world where opinion are controlled by, huge financial interest, and people do not want to think about how to get people together, how to do more grassroots things. The more sophisticated question, which might be not so easy to model, people do not think about, and it's definitely not something that I think that people in advertising do. Okay, so I guess our time is up.
Yep. One last question that is in chat that I'm going to read out. How long does each stage of optimal strategy take if points are chosen at random on sphere?
So, I think it depends on how many points. I guess you're talking about the situation where you have a single advertiser who can act over and over again. And this is really related to the question if you want to get optimal or close to the optimal, and it's really related to questions like margin, right? So there's going to be the optimal densest half sphere and the optimal densest half sphere. If you really want to take everybody in this half sphere, this will be determined by how close is the closest point to this hyperplane that's separated to these two half spheres. And then it's very easy to compute how many iterations it will get you to get as close as you want to be. So we didn't carry out these computations in the paper, but it's going to be a function of the dimension and how many points there are and so on and so forth. It's something, definitely a computation that you can carry out.
Great. I think there are no other questions I see. Well, thank you. It was an excellent talk. I guess if any other question that folks have, sort of, this is the last chance before we call it end of the day.
And feel free to email me, obviously, if you have other questions afterwards.
All right. Thanks, Elchanan. Sorry, somebody has a question.
Yeah, I was wondering if the optimal long-term strategies applied, then the goal V star would have to be orthogonal to W, the intervention itself. What would that mean?
Sorry, again?
In the optimal long-term strategy,
Yep.
The
V stars can be orthogonal to W. The way we move from W to V star is gradually. We're going to go from W to a vector close to W, a little bit in the direction of V star. Then we're going to do it again and again and again and again. This is how we're going to move our vector all the way to this orthogonal direction.
Right. How could we interpret this orthogonality?
Orthogonality just means that a priori in society, there was no correlation between these topics and all the other topics, between the last topic that we care about and all the other topics.
Okay. Thank you.